This question deals with a reaction inside a copper voltmeter that is similar to the idea of electroplating. The equation we have says that the mass of the material is equal to its chemical equivalent, represented by the letter Z, multiplied by the current multiplied by the time. For part A, we are asked to find the time. And so the equation will yield time equals mass divided by electrochemical equivalent times current. Now here, the mass is given as 7.5 grams, but we need to write it as a unit of kilograms. So 7.5 grams is equal to 7.5 times 10 to the negative 3 kilograms, whereby we might consider that the 10 to the negative 3 and the k kind of cancels each other out. So these values are equivalent. That gives us 7.5 times 10 to the negative 3 kilograms divided by the ECE of copper, 330 times 10 to the negative 9 kilograms per coulomb. The C there stands for coulomb, which represents charge, multiplied by 10 amps here in the denominator. Now, the unit of a kilogram will cancel with kilograms, such that the unit we are left with in the denominator here is amps per coulomb. When we divide that out, that turns into coulombs per amp, which gives us seconds. So when we do the math here, our time comes out to be 2273, and the unit is seconds. Now if we divide that by 60, we can say that that is equal to 37.9 minutes. Now for part B in this question, we want to show how you can find the time without knowing, I guess, the electrochemical equivalent of copper. And so the idea is that we can relate it to a ratio of hydrogen using the information given. Now, Reed's textbook, volume 6, in chapter 4, they presents us with the equation which says that the electromechanical equivalent of some chemical X can be found from the electromechanical equivalent as hydrogen, as long as we know the atomic weight of the material and the valency of the material X. And so if we are doing this for copper, what we're basically saying is that the electrochemical equivalent of copper will be equal to the electrochemical equivalent of hydrogen multiplied by the atomic weight of copper divided by the valency of copper. And you know, if we're doing that, the information presented for part B says that we have 10.4 times 10 to the negative 9 kilograms per coulomb as the electrochemical equivalent of hydrogen. We multiply that by the atomic weight of copper, given as 63.546, and divide by 2, which was the valency of copper. Now, that results in the electrochemical equivalent of copper as 330.44 times 10 to the negative 9 kilograms per coulomb. And that is basically the same as was given in part A of the question. And so that means the time will be equal to mass divided by Z times I will give us, and so that will give us the mass 7.5 times 10 to the negative 3 kilograms divided by the 330.44 times 10 to the negative 9 kilograms per coulomb. We just calculated, multiplied of course by the 10 amps, and we come up this time with a time of 2270 seconds, or 37.8 minutes, which is essentially the same answer that we had for part A.